Welcome back. Some great sessions today. Before we get started with our next session, we'll just give it a minute or two to let some folks join. Maybe grab a glass of water or something like that before we get started. Give it about a minute or two.
Yeah. Hello, everybody. Yeah, today we are prepared custom lab. This lab talking about the hybrid cloud ecosystems. Now, hybrid cloud ecosystem are the current way for develop really good scenarios over the cloud computing and fix all of different elements that all of different problems that we have when we try to deploy complex applications, enterprise applications, or big solution over the cloud. With us, we are participating in this laboratory, Freddy Montero and Hugo Guerrero, that I supported to me to create this laboratory and the explanation. But first, who is a hybrid cloud ecosystems? Or what is this? Hybrid cloud ecosystems is a key one big definition of what new way for create applications or create microservices. The idea is integrate the key features for every cloud ecosystems or every cloud computing. One of these key features are the integration public and private clouds, because working in that two clouds together integrate the flexibility, the idea of create applications with all of this flexibility to migrate into between the different cloud providers or on-premise. Unified management is one of big ideas of that hybrid cloud ecosystem. Create dynamic scalability, support security and compliance over the cloud, and maintain the security and compliance over the different clouds and platforms. The application portability and reducing vendor locking is one of the big important topics of that. And one of these ideas is aligned to open industries. Because currently all of different people try to deploy and develop applications over or focus only in one or two microservices, and after that thinking how to integrate that. The idea of the hybrid cloud ecosystems is developed thinking in a vertical of industry, thinking about the full complex scenario and how to manage or how to develop this scenario and transversal elements. Now, when talking about the how to create hybrid cloud ecosystems, we have a different challenge, because have the challenge of develop over the hybrid cloud development, over the hybrid cloud infrastructure, and how to integrate all of that between different platforms. What does the principal challenge that we have is manage complexity, because microservices presents a greater complexity in the management of multiple independent services, each with its database, business logic, etc. And consistent and distributed transaction. This is important because now the application deployed over different platforms, over different clouds, need to maintain the data consistency and microservice environment, especially in operators that involve distributed transactions, can be complicated and require specific solutions. And talking about the security and data protection, because this point is important in the cloud computing, hybrid ecosystems, and every develop or deploy scenario. Monitoring that, and now we have different scenarios, different platforms, and we need to be the tracing and idea what happened in all of that complex infrastructure and complex deployment. And talking about the cultural organization challenge, is about that now we focus in open industries. The hybrid cloud ecosystem is focused in talking about the open industries and mapping all of 20 open industries that currently exist and currently are focused for all of different scenarios or different ecosystems. And network overload and latency, because we need to integrate and balancing all of different applications and manage this application over the current infrastructure, current application, and connect to the backend and connect with the other microservices or other hybrid cloud ecosystems. Okay, now we will talk or we will introduce to the lab objectives. The first thing is the architecture. That current architecture for that laboratory is mapped in this link. I don't know if we can share the link into the chat. Okay, we can share the link in the chat, but, and we can talk about this architecture. This architecture is based in three OpenShift clusters. Could be Kubernetes cluster. In this case, we're using the OpenShift solution. This OpenShift solution is based in AWS cloud provider, OpenShift 4 version, and we introduce in this OpenShift 4 the Red Hat Advanced Cluster Management and Kubernetes, and OpenShift Data Protection, OpenShift DR, and different operators like Submariner and OpenShift Interconnect that is based in Scooper. The architecture maintain the consistency in these two clusters. We talk in the different parts of this laboratory. OpenShift 1 and OpenShift 2 is principal and secondary cluster, and hub cluster that this cluster manage all of different instances about or all of different elements over the OpenShift cluster 1 and OpenShift cluster 2. This cluster have set all of different elements, metrics, and observability. And in all of that clusters, OpenShift 1 and 2, we deployed the different applications. That the idea is validate, build, and deploy these applications and manage the DRP scenario. Okay, now we can check the different materials that we are preparing for us. We prepared this little document, and I shared with you the link over the chat. In this link, we can see all of different endpoints for enter and follow the different activities, and follow me doing this laboratory. And if you have any things to test over the laboratory, you feel free for connect and follow and do the different elements. How to connect to this laboratory? You can enter in the users tab, and in the user tab you can see all of different users for the different clusters. And
I think I think the file that you're sharing is under the Red Hat account, so it's not publicly available for anyone that it's not on the same organization. Can you use your personal email account or to
yeah,
share it?
let me check. Let me. I am validating that. Okay, let me a second. Okay, let me create. Let me a second. I am mapping the document in another. Okay, let me a second. Yeah, and in well apply the document. I explained that currently I put different clusters. The recommended clusters are marked in green. And you can use all of other cluster for follow the different activities. Okay, let me share with you again the document. I'm sharing the link in the chat. Perfect. Now is the new link for the lab. Will you validate you if it's
Yeah, that's working.
perfect? Excellent. Thank you. Yeah, now you can put your name, your email.
So that's the second tab, right?
Yeah, the second tab is for the user, and in the top of any cluster have the password. It's the same password for all users. And in the clusters, you can choose the endpoint because we need to use the cluster hub, OpenShift 1 and OpenShift 2 cluster. Two cluster. Okay.
Okay, so that basically means that the on the second sheet where you're saying users, you have 5 different users. So that means that that's a cluster that can handle 5 users, and any one of the attendees can just fill in their name in one of the rows of the user from 1 to 5. And on the first sheet, there's the clusters information. So you will be able to get the URL for the 3 components of the architecture that Herbert was mentioning before, where we have a cluster hub, OpenShift 1 and OpenShift 2 for each one of the different clusters. So just type in your name and the email and or just your name, just
Yeah.
just to know that you are going to be using that user. For example, I just filled in for the user 1 on cluster 2. um, I mean, it doesn't need to be a real address. We're not collecting any information, don't worry about that. It is just for us to know that you are using that cluster, and your name just to reference if you have any questions or comments that you want to do, so we can help you out with that. And yeah, please, sir, go on.
Perfect. Thank you. Okay. Now we start with review the project's materials in the GitHub that I share in the chat. And if you don't have, I share again into the chat. Okay. We can review different elements in the requirements and requisites. We can validate that currently have all of different elements and scenarios that we can introduce. For this lab, all of different elements, this part of the laboratory is already being provisioned become a more quickly laboratory. Focus on deployment on the different items and different scenarios that we need to test. What need to install if you want to create your lab is install Ansible, AWS CLI, Python, setup tool, Submariner, and Scooper CLI. Yeah, you need to configure different variables. Yeah, and with this section you can deploy all of different elements that you need to get. You can do a Git clone for this scenario or for this Git if you want to get all of different materials for implement your cluster or create your own sandbox laboratory. Okay,
Yeah.
now.
So one second, Ever. So basically, the gist of it is a lot. Most of the bulk of the work has been provisioned for you guys. So there's going to be a lot of troubleshooting, so you guys can hit hands-on and troubleshooting stuff. But like Everett said, is you guys going to have access to the Git clone, to the Git repository. You can clone it, and you can you can try this out in your house. Most likely, you guys are not going to be able to go through every single exercise, try it out, the troubleshooting, see how it's set up. That way you guys get some sort of idea. But again, at the end of the day, you guys are going to have access to the Git repository, clone it, and you can basically try this at your leisure, at your pace, in your home.
Yeah, right. Thank you, Freddy. Yeah, and now starting verify the current laboratory. Now we login into the cluster hub and enter to local cluster, choose all clusters, and validate that you have the local cluster and you see the primary and secondary cluster, that is OpenShift 1 and OpenShift 2. We refer all of that cluster during the laboratory. Other validation that we need to do is validate the current channel subscription and placement API to the. Currently, the placement is old and in the maybe in the new versions for OpenShift new versions will be deprecated, but currently we use in that laboratory and the application. Some of different commands that we need to use in this laboratory is ocgpot and ocreate file with the name of the file. That is important because we need to create that. We refer to the Git, download the YAML or create the YAML and create this YAML over the OpenShift. Okay. Now with ACM and this strategy, we solve the first challenge: management and complexity. In the top of the laboratory, you can see all of different challenges that we need to resolve for create a really good hybrid ecosystem. And this is our way to how to resolve these different issues. Okay, and the first was a management complexity. We resolved with ACM and all of that prerequisites that we deployed, Submariner, Scooper, and different operators over OpenShift and OpenShift Data Foundation. Now the second challenge is consistency and disrupted transactions. This section we resolve, deploy and configure Scooper operator, Submariner operator, and all of that elements. And now we validate in our laboratory that we have in a lot of different clusters view. Sorry, in the local cluster for the all of your clusters, cluster 1, cluster 2, and managed cluster. C2 operators, installed operators, and validate that we have the advanced cluster management, ODF multi-cluster orchestrator. This is for, and this with Submariner we use for configure the DRP plan and Red Hat Service Interconnect. Okay. Then now we need to validate that the cluster network in the both cluster is not overlapping, because when we try to manage that replication in the DRP plan, it's necessary to validate that currently don't have the same CID error, the address in both clusters. How to check that? On OCP1 and OCP2, validate with this command. Okay, I have the command line. How to access to this command line connections? You go to user, copy login command, open this web portal, and you only copy the login with this token. This web portal generate a token for manage your login. Okay, then we need to check and validate the current network. For the OpenShift 1 is 10.128.0.0, and now for cluster 2 is 10.200. Okay, we are well done for that. Now that means that we configure and prepare with Submariner and OpenShift data recovery. Perfect. Now we need to verify that the cluster set is ready, because we balancing and orchestrating over 2 different clusters. We need to enter into the cluster hub. Okay, into the cluster hubs, go to infrastructure clusters, and validate that we see ready all of different clusters. Okay, is now we click in the cluster sets and check the cluster set 1. That this cluster set is preparing for validate all of that elements. Checking cluster list, and the clusters are ready for manage all of that. You can see the Submariner add-ons and validate the current. Now Submariner is installed in both clusters. Okay. Perfect. Now, for the security and data protection, we can validate that OpenShift Data Foundation is healthy, and the database that currently we will deploy databases on our clusters are ready. How to validate that? In cluster 1 and cluster 2, we can check with this command. Okay. Okay, and then the storage operator is ready. Yeah, I am only validating in one cluster, but you will validate in the both clusters. And Nova is ready. Okay, perfect. Then we need to check the all of different pods that we have in OpenShift operators, because we need to validate that we have a lot of different operators. In that case, Scooper, that is necessary for this packer, and operator. We need to see that operator controller and other operators. Let me change to hub or see another. Okay, then we have the ODF FMO controller, ODF multi-clusters, and Scopper. Perfect. And now validate the data policy on hub cluster. How to validate that? We enter in the cluster hub, go to data services, data policies, and validate that currently the data policy is well. I currently have this data policy in your cluster. Okay, now in the monitoring part, we are put all of that different elements, and currently in the cluster is enable a monitoring tool, but it's a common and out of the box capability. It's for the reason that we jump to the next part. And now testing the continuous deployment. The idea is testing, in that case, create application in the primary cluster, and after that, test this failover over the cluster. Okay. For create that this application, we need to review or follow that all of that instructions. Okay. Now we go to the cluster and enter to the cluster the application one. Okay, now the OCP one for deployed the application. And first, okay, sorry. First, we need to create the profile. The idea of that cluster or that scenario is create a profile that is a part of an important part of this laboratory. Create this profile available in the local cluster, that is hub cluster, primary and secondary. How to create that profile? Okay, we put in or we create the namespace globex over the all of different clusters. How to do that? Okay. Over the different projects. Okay. Perfect. Now we can create the application subscription. We go to the hub cluster. Okay, go to applications. Okay. Validate that we have all of the different applications, and go to subscriptions. Click in create application. Okay. Subscription. Okay. In that case, we can use all of different elements. In that case, the name is Lovex. The namespace is the namespace that we are creating for that scenario, and we can use this GitHub. The branch is main. Okay, and we can select the current clusters for this scenario. Okay. But okay, this in configuration is, and put the environment. Let me put them. Okay, it's always active and deployed to all online cluster to on and local cluster. Okay, is perfect. Okay. Now Gravis is creating. We need to wait 2 minutes for complete this part. Okay. Perfect. Yeah. Now go back to the applications. And validate that currently is Globex. Globex app is created on our cluster. Perfect. Now, on the cluster 1, we go to networking routes, to cluster 1, projects, Globex. Okay. And validate that currently Globex have a link. In that case, the UI is Globex UI. Okay, click and validate that currently is a good. Perfect. We have this application. You could be navigate over the application, and now we're go. And now we can validate that the current route is well over all of different clusters. Okay. Now let me check. Take cluster 1. Okay, currently we have the route. Cluster 2. We have the route. Perfect. Okay, now have the same URL, only is changing for the name of the URL. Perfect. Now we're testing the failover. Now we have the failover over the first element. We need to set the pod variable because the pod name is changed over the different clusters, and we need to set that. You be sure that you choose the correct pod, and if you try to do manually. Okay, let me change to Okay. Okay, I set the variable. And now update the element of the post on the Postgres database. Now you need to see that update one, that currently we update that element, and we update in the cluster, we can say that Quarkus t-shirt now is 15. Okay, it's the Quarkus t-shirt. Let me check. Check that. Okay, yeah, this Quarkus t-shirt is 15. Now, if we check this the same into the cluster too, because currently don't have the balancing well configured. We don't have the Quarkus t-shirt. Okay, perfect. Now we go to the return to the ACM or hub cluster. This is the principal hub cluster, and good data services data. Okay, in the data policies, go to the element that currently validate that currently have this element. Okay, perfect. Click in the configuration set, that is 3 dots. Okay, for edit this element. And in that case, we can use the 3 dots for disaster recovery policy and select apply DRO3 policy. Perfect. Okay, we validate that we choose the environment demo and apply the Globex. Okay, now we applied this data recovery for this application. Now we're using Submariner to synchronizing all of these elements over the application and database. We're going to we can validate all of that. This other instruction as for the cluster 2, but now we have the cluster 2 configured well with this the first element. No, because yeah, if we go to the cluster 1, we have the Globex serve project and the project. Yeah, we have the project 2 in the Globex element. Perfect. Now, in the cluster 2, we do this annotation for configure the same subscription over the GlobeX application in the cluster 2. With this annotation, we can see in the ACM again and apply the failover application for configure or for apply all of that elements in the bot in the bot clusters. Let me a second. Okay, now show that don't need to apply anything because let me check. Yeah, currently don't have the scooper balancing configured and only show in one service. Perfect. Now, if we can go to the primary cluster for validate the terminating the application in the cluster 1 and validate after that the PVC for validate that the data is maintained over the cluster. Okay. You can go to cluster 1. Okay, and currently the health of the storage is well, the persistent volume is well after the policy is applied. Validate the PVC of the cluster 1. And we do the same for the cluster 2. Okay. Okay, the PVC is okay. But currently the PVC is not well. Let me check what happened. Okay. Demo, okay. Yes. Is well. Let me a second. Okay, we don't have any. Okay, now we try to do the failover for this application. You can do with this same scenario. The in the web console, if you don't do the, or if you have any issues into the command line, maybe someone in the cluster changed something, but no worries. We have the failover application. Okay, let me check. Perfect. Okay, and now we recover the site. No, this I need to change the Scooper configuration, because Scooper in the first view we can see that Scooper maintain the balancing over the different elements. In that case of the backend services, and if you see that into the one cluster don't have any pod configured, but we have configured the route and the service. And if we use these different services over the same the same hybrid ecosystem, we can balancing and consume all of different elements over the platform. And with Submariner, we have the capability to migrate all of different elements, database, PVC, and applications over the different clusters for a disaster recovery plan, or for any problems or any issues that you have in the real life. Okay, and now we validate that all is well. Let me return to the cluster one. Okay, we don't have the volumes here, because the volumes are migrated to the second second cluster. Perfect. Now we talking about over what is the current strategy about the cultural and organization change. The implementation of these different ecosystems, or the idea of this different ecosystem, is with all of that scenarios, or what all of that infrastructure capabilities and operators, we are able to deploy and configure applications based in microservices involved in open ecosystems. We suggest 20 open ecosystem, and these open ecosystems are aligned to the different verticals and industries over the world, and they currently are defined for the different companies for the 20 principal open industries into the market. I put these 20 and explain what is in any of that industries. And the idea is with all of this ecosystem, all of that elements, we are able to deploy any different ecosystem over that. For example, we can create on the any application. We can use any clusters. In that case, we use the cluster one for that. You can use any other cluster. Perfect. And we can deploy any open open ecosystem. For example, now we can deploy the open education environment. Now we can validate that they currently don't have the project. Okay, and return to the clusters. Go to application, create application subscription. With that, we can deploy with putting the Git, for example. Sorry, its name Open Education. The name is the same, Open Education. We can use the different Git. In that case, is the Git for Open Education path. Education. We choose that this is deployed in the all of clusters and local cluster. Perfect. Or you can create with YAML. No, but this is the same scenario. And with this same strategy, if you go to the projects, let me check it. Applications. Okay, maybe it's configuring. A second. Okay, we need to validate in the local cluster. We check and validate the current configuration in networking routes, for example, services, but and validate deployment. Okay. Okay, maybe we need to change the path. Something else. Wait a second. Let me check if the grid is not created. Maybe. Okay, we need to check what happened in that for that. But it's the same configuration. You can see all of that elements for create any of the open educations. In our GitHub, we refer of different open ecosystems, and we are working in all of different ecosystems patterns for that. And you can review other open ecosystem patterns for different verticals and companies. And I think is all for now. With this little demo, we can see what is the useful mining and useful way for deploy all of different complex solutions and into the open ecosystems and align to the different strategies for fix the current challenge for deploy application over the cloud. Okay, I don't know if in the questions we have any questions, any.
No, I think there's no more questions. Whatever, can you give us like a high overview summary of what is the best benefits from these kind of ecosystems?
Yeah. The first benefit is because if you focus now into the ecosystems, like in the real life, you are able to deploy fast, and you are able to maintain the consistency of your different infrastructure, because you manage all of that like a current natural of or society ecosystems. The idea is maintains the similar patterns that how to work in the real life any industry into the virtual deployment of the cloud. If you deploy with this way and this structure, you be sure that have resolved security, resolve the disaster recovery plan, because now in thinking about over the cloud, the different cloud providers have the same or the self disaster recovery plan itself, but you need to adapt if you need to manage the two different cloud providers, or you have a on-premise and cloud provider. And if you working with a hybrid cloud ecosystem, you thinking about all of this scenario like only one big element. And DRP is not naturally created, and your applications or your users don't have any impact or incident time if something happened over your application operation.
Perfect. Thank you very much. I'm sharing again the link on the chat. So if you want to go over the all the instructions that were covered today and maybe check on what are different ways to set up this, you can find those there. So thank you very much, Greg. Back to you.
Yeah, thank you everyone so much for joining today. And we will be back in about 3 or 4 minutes with our final presentation of the day. So we'll see you soon.
Okay, thank you.
Thank you, guys.